NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will solve quadratic equations step by step using the quadratic formula. We'll introduce the discriminant, explain the three cases, and finish with a fully worked example. First, let's place an example label. Then, we show the general quadratic equation, ax squared plus bx plus c equals 0. Step 1. State the quadratic formula. The solutions are x equals negative b plus or minus the square root of b squared minus 4ac, all over 2a. Step 2. Define the discriminant. We let capital delta be equal to b squared minus 4ac. Step 3. Rewrite the formula using delta. Now we have x equals negative b plus or minus the square root of delta over 2a. Step 4. Consider the three possible cases for delta. If delta is greater than 0, there are two distinct real roots. If delta equals 0, there is one repeated real root. If delta is less than 0, there are two complex conjugate roots. Step 5. When delta is positive, the two real roots are given explicitly by these expressions. Now, let's work a complete example together. We will solve x squared plus 3x plus 2 equals 0. First, compute delta. Here it equals 1, b equals 3, and c equals 2. Delta equals b squared minus 4ac, which becomes 9 minus 8 equals 1. Since delta is positive, we expect two distinct real roots. Next, substitute into the quadratic formula with delta equal to 1. That gives x equals negative 3 plus or minus 1 over 2 times 1. Then simplify to negative 3 plus or minus 1 all over 2. 3 plus or minus 1 all over 2. Finally, split into the two cases. In this video, we will solve two quadratic equations using the quadratic formula step by step. Example. Our first equation is x squared minus 3x plus 2 equals 0. Step 1. Compute the discriminant delta equals b squared minus 4ac. For a equals 1, b equals negative 3, c equals 2, we get delta equals negative 3 squared minus 4 times 1 times 2 equals 9 minus 8 equals 1, which is greater than 0. Step 2. Apply the quadratic formula. X equals negative b plus or minus the square root of delta, all over 2a. Substitute the numbers to get x equals negative 3 plus or minus the square root of 1 over 2 times 1, which is x equals 3 plus or minus 1 over 2. Step 3. Compute the two roots. So the roots are x1 equals 2 and x2 equals 1. Example. Our second equation is 7x squared minus 8x plus 1 equals 0. Step 1. Compute the discriminant delta equals b squared minus 4ac. With a equals 7, b equals negative 8, c equals 1, we get delta equals 64 minus 28 equals 36, which is greater than 0. Step 2. Apply the quadratic formula. Substitute to obtain x equals negative 8 plus or minus the square root of 36 over 2 times 7, which simplifies to x equals 8 plus or minus 6 over 14. Step 3. Compute the two roots. The roots are x1 equals 1 and x2 equals 1 over 7. Recap. The algorithm stays the same. Compute delta, apply the quadratic formula, then simplify to two roots. When delta is positive, you get two real solutions. Practice a few more to build speed and confidence. In this lesson, we will solve two quadratic equations using the quadratic formula. We will follow the exact step sequence. First compute the discriminant, then apply the formula, and finally simplify to the roots. Example. Our first equation is x squared plus x minus 2 equals 0. Step 1. Calculate the discriminant delta equals b squared minus 4ac. Here it equals 1, b equals 1, and c equals negative 2. Substitute those values and compute delta. Since delta is positive, the equation has two real roots. Step 2. Apply the quadratic formula. X equals negative b plus or minus the square root of delta, all over 2a. Substitute a equals 1, b equals 1, delta equals 9. Now simplify to get the two roots. Example. Our second equation is negative 3x squared plus 7x minus 4 equals 0. Again, step 1 is the discriminant. Delta equals b squared minus 4ac. This time it equals negative 3, b equals 7, c equals -4. Substitute and compute delta. Delta equals 1, which is positive, so there are again two real roots. Step 2, apply the quadratic formula again. X equals -b plus, or minus the square root of delta over 2a. Now substitute a equals -3, b equals 7, and delta equals 1. Simplify to get the two roots. In this lesson, we will solve two quadratic equations using the discriminate and the quadratic formula, following the exact step order. Compute delta, determine the number of roots, apply the formula, and then compute each root. Example, we solve 5x squared minus 3x minus 8 equals 0. First, compute the discriminate. Delta equals b squared minus 4ac. Substituting at equals 5, b equals -3, c equals -8. We get delta equals parenthesis -3 squared minus 4 times 5 times -8. That is 9 plus 160. So delta equals 169, which is greater than 0. Therefore, there are two real roots. Now apply the quadratic formula. X equals -b plus, or minus the square root of delta over 2a. Plug in the values to obtain x equals 3 plus, or minus 13 over 10. Finally, compute each root. X sub 1 equals 3 plus 13 over 10 equals 16 over 10 equals 8 over 5. X sub 2 equals 3 minus 13 over 10 equals -10 over 10 equals -1. Example, now solve 7x squared minus 5x minus 2 equals 0. As before, start with the discriminate. Delta equals b squared minus 4ac. Substituting at equals 7, b equals -5, c equals -2. We get delta equals parenthesis -5 squared minus 4 times 7 times -2. That is 25 plus 56. So delta equals 81, which is greater than 0. Two real roots again. Apply the quadratic formula. X equals -b plus, or minus square root delta over 2a. That gives x equals 5 plus, or minus 9 over 14. Now find each root. X sub 1 equals 5 plus 9 over 14 equals 1. X sub 2 equals 5 minus 9 over 14 equals -4 over 14 equals -2 over 7. In this lesson, we will reproduce the exact step-by-step solution shown in the provided context image. We will solve the quadratic equation, bx squared minus quantity a plus b squared times x plus ab equals 0, with the condition is greater than b squared. We will first compute the discriminate, then apply the quadratic formula, and finally simplify both roots. Step 1. Compute the discriminate. Delta equals b squared minus 4ac. Then substitute a equals b equals negative quantity a plus b squared, and c equals ab. Carefully expand exactly as in the reference solution. Since delta is positive, the equation has two real roots, exactly as stated in the context image. Step 2. Write the quadratic formula, then substitute the values and the simplified discriminate, following the exact order. Step 3. Simplify each root exactly as in the image. First add, then subtract, and reduce the fractions. Therefore, the two real solutions are a over b and b. This completes the solution, matching the exact algorithm and ordering of the provided context. In this example, we will solve a rational equation step by step. Here is the problem. Before we start, note the domain restrictions. Y cannot be 0 and y cannot be 2 to avoid division by 0. Step 1. Clear fractions by multiplying both sides by the least common denominator, y times y minus 2. Step 2. Expand the product on the right. Y times y minus 2 equals y squared minus 2y. Step 3. Bring all terms to one side and collect like terms. This gives y squared minus 4, y minus 2 equals 0. Step 4. Compute the discriminate. Here a equals 1, b equals -4, and c equals -2. Delta equals b squared minus 4ac, which is 16 plus 8 equals 24. So delta is positive. Step 5. Apply the quadratic formula. Y equals -b plus, or minus the square root of delta. All over 2a. Substituting gives 4 plus, or delta. All over 2a. Substituting gives 4 plus, or minus the square root of 24 over 2. That simplifies to 2 plus, or minus the square root of 6. Finally, check the domain. The values must not make a denominator 0. Since 2 plus or minus the square root of 6 is neither 0 nor 2, both solutions are valid. Here is the final answer. In this example, we will solve a rational equation step by clearing denominators, simplifying to a quadratic, and using the quadratic formula. First, note the domain restrictions. Denominators cannot be 0, so x cannot equal 0, and x cannot equal -1. Step 1. Clear fractions by multiplying both sides by the least common denominator, which is x times x plus 1. The x cancels with x in the first term, and x plus 1 cancels with x plus 1 in the last term. We obtain 6 times x plus 1 on the left equals 2x times x plus 1 plus x times x minus 3. Next, expand and collect like terms. This becomes 6x plus 6 equals 2x squared plus 2x plus x squared minus 3x. Move all terms to one side to get a quadratic equation. Compute the discriminant delta equals b squared minus 4ac. Here is 3, b squared minus 4ac. Here is 3, b is -7, and c is -6. Delta equals 121. Apply the quadratic formula x equals -b plus or minus the square root of delta over 2a. That yields x equals 7 plus or minus 11 over 6. Finally, check these candidates with the domain restrictions. Neither 3 nor -2/3 equals 0 or -1, so both are valid solutions of the original equation. Therefore, the solution set is x equals 3 or x equals -2/3. In this lesson, we will solve a rational equation step by step, follow the exact sequence shown on screen, and visualize each transformation. Here is the problem. We will also mark the domain restrictions up front. The key first step is to clear fractions by multiplying both sides by the least common denominator. The denominators we see are 2 minus p and p. So the least common denominator is 2p times the quantity 2 minus p. Step 1. Multiply every term by the common denominator. Be careful to write the entire left side in brackets before multiplying. Step 2. Distribute and simplify each side. 2p squared plus 8 minus 4p on the left, and -6p plus 3p squared on the right. Step 3. Move everything to one side to form a quadratic. Now compute the discriminant. Step 4. Apply the quadratic formula. That leads to p equals the quantity 2 plus or -6 all over 2. So the solutions are p equals 4 or p equals -2. Finally, check the domain restrictions. P cannot be 0 and cannot be 2. Both answers satisfy the restrictions. In this example, we'll solve a rational equation step by step. The equation is the quantity 5x minus 1 divided by x plus 1 equals 3x over 2. We'll clear denominators, form a quadratic, and solve it carefully. First, note the domain restriction. Because x plus 1 is in the denominator, x cannot be -1. We'll remember to check our final answers against this restriction. Next, clear the denominators by cross-multiplying. Multiply both sides by 2 times the quantity x plus 1. That gives 2 times the quantity 5x minus 1 equals 3x times the quantity x plus 1. Now distribute to expand both sides. 2 times 5x minus 2 equals 3x squared plus 3x. Bring all terms to one side to form a standard quadratic equation. Subtract 10x and add 2 to the right side, or equivalently move everything to the left. Compute the discriminant to confirm we have real solutions. Delta equals b squared minus 4ac. Here it equals 3, b equals -7, and c equals 2. Delta is 25, which is positive, so there are 2 real solutions. Apply the quadratic formula. X equals -b plus or minus the square root of delta all over 2a, substitute it equals 3, b equals -7, and delta equals 25. Evaluate the 2 possibilities. 7 plus 5 over 6 gives 2. 7 minus 5 over 6 gives 1/3. Both values are not -1, so they are valid solutions. In this example, we'll solve a quadratic equation step by step, mirroring the solution structure shown in the reference. Example: the equation is open parenthesis, 5x minus 3, close parenthesis, times, open parenthesis, x minus 5, close parenthesis, equals, open parenthesis, 2x plus 5, close parenthesis squared, plus 90. Step 1. Expand both sides. Expanding the left side using FOIL gives 5x squared minus 25x minus 3x plus 15. Expanding the square on the right gives 4x squared plus 20x plus 25. Then add the 90. Step 2. Combine like terms on each side. On the left, minus 25x minus 3x becomes minus 28x. On the right, 25 plus 90 becomes 115. Step 3. Set the expanded forms equal and move everything to the left so the equation equals 0. 5x squared minus 28x plus 15 equals 4x squared plus 20x plus 115. Subtract the right side from both sides to get x squared minus 48x minus 100 equals 0. Step 4. Identify coefficients and compute the discriminant. Here it equals 1, b equals negative 48, and c equals negative 100. The discriminant delta equals b squared minus 4ac, which is negative 48 squared minus 4 times 1 times negative 100. That equals 2,304 plus 400, which is 2,704, greater than 0. Step 5. Use the quadratic formula. X equals negative b plus or minus the square root of delta over 2a. Substituting numbers gives x equals 48 plus or minus 52, all over 2. Step 6. Compute both roots. First, x equals 48 plus 52 over 2, which is 100 over 2 equals 50. Second, x equals 48 minus 52 over 2, which is negative 4 over 2 equals negative 2. In this lesson, we solve a rational equation that turns into a quadratic. We will follow the exact step order shown on screen. First, here is the example. Step 1. Rewrite the right side with a common denominator. Think of 1 as x plus 7 over x plus 7. Then combine the fractions. Step 2. Clear denominators by cross-multiplying. Multiply numerator by opposite denominator. Step 3. Expand each side using the distributive property. Write every term before simplifying. Step 4. Bring all terms to one side and combine like terms to get a standard quadratic. Then simplify. Step 5. Compute the discriminant to prepare for the quadratic formula. Here it equals 1, b equals negative 9, and c equals 14. Step 6. Apply the quadratic formula. Substitute a equals 1, b equals negative 9, and delta equals 25. Step 7. Evaluate the two solutions. These are the two real roots of the original equation. Final answer, x equals 7 and x equals 2. Always check that denominators are not 0x, must not be negative 7. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.